evening we're going to talk about the real number system. We talked about it a little bit in our first weekly synchronous session, but the whiteboard function wasn't working the way I wanted it to, so I wanted to just kind of review it for those of you who were present and also for those of you who weren't, to talk about different types of numbers because it's really the foundation for this entire unit of study. Okay, so when we talk about the number system, everything in these circles is representing the real number system. Okay, so the reason we start talking about it with these circles is to show you that everything in the center is included by all the rings that surround it. That'll make a little bit more sense when we start talking about it. The first type of number that we talk about is the natural number. These numbers are also sometimes called the counting numbers because they're literally the counting numbers that you learned when you were small and first learning about numbers. Okay, so the natural numbers start at 1. And I'll just put a few examples of each type of number in the ring. They're by no means all of the natural numbers or all of the subsequent numbers. I'll just give you a few examples to kind of give you an idea. So natural numbers start at 1. 2 is also a natural number. 3, 4, 10 is also a natural number. 12, 100. These are just some examples of natural numbers. Basically, natural numbers are all positive. They are all whole numbers, meaning no fractions, no decimals, no ratios. They're all whole numbers. No 1.5, no any kind of fraction. They're all whole numbers. 1, 2, 3, 4, 5. They're all whole numbers. They are all positive. It does not include the number 0. They're the natural numbers, starting at 1, going up to infinity, but all positive, all whole numbers. All right, the next type of number we have is very similar to natural numbers. We have the whole numbers. Okay, whole numbers are also positive. They are also whole, no fractions, no decimals. But the set of whole numbers includes the number 0. So we have 0, 1, 2, all the way up to 5, 10, 1,000. These are all whole numbers. They are positive, no fractions or decimals, no pieces of numbers. And they are moving upwards from 0. They include 0. An easy kind of silly way to remember that is if you think about whole numbers like a donut hole, and the donut kind of looks like 0. It includes 0 in that set of numbers. All right, this next ring here, and if you notice, natural numbers are included in whole numbers. It's the circle in the middle. It's included in whole numbers. That's why it's inside of it, because all of these numbers are also whole numbers. Okay, here we have integers. Integers consist of positive and negative whole numbers. No fractions yet, no decimals yet, but we do add in negatives. So it does include 0, because it includes the whole numbers. Remember, anything in this ring is a part of integers. It's inside of it. These are all the positives. Okay, so we have positive 1, positive 2. But integers also include negative numbers. Negative 2, negative 4, negative 10. Okay, all the way to the left of 0 on the number line. Okay, whole and natural numbers are included in integers. This outer ring here includes tons of numbers that we could never show, but I'll give you a few examples. We can never show all of them. They are rational, with an R, numbers. We also talk about irrational numbers later on, so I want to be careful when I pronounce it that you understand that it is rational numbers. Okay, rational numbers are any number that can be expressed as a fraction, okay, or decimal. The root word of rational is ratio, which is a kind of fraction. That's a good way to remember it. Any number in this outer ring can be represented as a fraction. So it does include all of these. It includes 1, 2, 3. It also includes 0 because we have the whole numbers included. Okay, and you may be thinking, how can 0 be represented as a fraction? Right, but when we think about, let's say, 0 over 2. That means 0 divided by 2, which equals 0. So that's a way to represent it as a fraction. Okay? It also includes negative numbers, -2, -5, -10. And like I said, it includes fractions and decimals. Okay, so 1/2, 3/4, 12/13. All of these numbers can be included in rational numbers. We could do 0.0124. It's a decimal, it's included. Okay, we could say 2/4, which we know turns into 1/2, but it's represented as a fraction, so it's included as a rational number. Okay, so rational numbers include a whole lot of numbers, but they are any number that can be represented as a fraction or decimal. It includes all the integers, all the whole numbers, and all the natural numbers. Okay, out here, this little triangle out here, we won't have to deal with yet, but it's worth mentioning because these are what are called imaginary numbers, which you won't be dealing with in this semester, but you will be dealing with later on in your mathematical career. And they are not included as a part of the rational number set, the real number set. They're separate, so that's why we include that there. Okay. The only other type we have in the real number set are irrational numbers. So it would not be represented as a ring, so I don't want to write it there. There's another type of irrational numbers that cannot be written as a fraction. For example, pi. Okay, so we could draw another triangle out here for it. Irrational numbers are numbers that you cannot, no matter what you do, you cannot write it as a fraction. So pi, we all know that it is 3.14 when it's abbreviated, but really pi is a number that goes on for infinity. 3.14 is an abbreviation. Pi actually goes on infinitely, so it is not a rational number. You cannot represent it as a fraction or a decimal that stops. Okay? So that's it. That's the first introduction to what we kind of want to talk about. This graphic organizer, this diagram, is actually included in your course content, but there's not examples, so I just kind of wanted to go through and talk about it and add in some examples. Okay? All right, have a good night.